Well, thank you everyone for being here today with us this morning. Just before lunchtime, I know sometimes it's a bit tricky to get this slot, and after lunch also, so I hope you will not run away too fast after. Just welcome to this technical workshop on certification and design verification of UAS. It's a dry topic usually. I hope we will make it a bit more fancy today and less mystery. I'm sure all of you know a lot of acronym behind the regulation, Sora, SAIL, OZOs, and a lot more actually. I'm a bit lost myself sometimes, so I need to ask Antonio, who's there, to please remind myself. This session is for you. To get a bit more hint on the practical way to get your drone flying in the airspace. So yeah, at least as a machine, to get the design verification process through, what it is about, and sometimes to certification. And you have the opportunity here to have a top-notch panel who have hands-on and have a project running or even closed for some of them very recently. So they've been through the process, they know what they are talking about, and they can really help you to guide you on what's the good stuff to be done and the one that are working a bit less. So just to remind also, Slido, the number is 437065. That's where you can really post all your questions, and we'll do our best to answer all of them at the end of the session, or at least before the end of the session. I'll introduce myself, sorry for that. I'm David Soraa, I'm from EASA, and I'm the head of the General Aviation and the VTOL department in the Certification Directorate, which is covering, among others, the US, the light US drones within our organization. I will introduce the panel members so that you know who's there. And ladies first, so, and I really excuse myself for, pronouncing the names sometimes a bit the French way. I try to get rid of this accent since ages, and I'm fearing I will fail it forever. So Marta CEJUELA is the safety manager and head of Airworthiness of Flying Basket. She manages and oversees the organization's activity and is responsible for also the Flying Basket's operational safety and design requirement to comply with the US regulations. She's also the Flying Basket representatives in several international working groups related to UAS matters. And Marta has a strong background in initial and continuous airworthiness, safety risk management, regulatory compliance of civil and defense aviation regulations. Marta is also leading, since October 2021, the EuroCAE Working Group 105, Subgroup 4, where you have the objectives to develop guidance on UAS and means of compliance associated to the special conditions like UAS. And she is also participating in the working group on the initial airworthiness for the rulemaking tax 230, which is, the big one on UAM and the like. So be with us today. Marta is the right person. We have also Ronald Liebscher. Sorry, you raise your hand, Ronald. He's the senior expert in aviation regulation in Volocopter. Ronald is an aerospace engineer with more than 10 years experience in the manned and unmanned aviation sector. He's working as a senior expert in aviation regulation within Volocopter. He's actively involved also within regulation and standardization activities of UAS and eVTOL, also in the working group 230 within EASA regulatory framework, U-Space expert group, JARUS SRM working group, and EuroCAE 105, and working group 112 on eVTOL. So he was a former director of Technical Standards Europe for the drone manufacturer DJI, and he handled the standardizations and technical regulation task for UAS in Europe. In Berlin, he was also at the Berlin Airport Company, and he was the project leader to develop and build a new heliport for the airport that was involved also in the EASA certification specification for VFR heliport on aerodrome. So that's Ronald is passionate about developing all these solutions around the place, and really looking forward to discuss with him a bit in a few minutes.
Thanks.
We have also Simone Menuchi. Simone?
Yeah, yeah,
Yes.
MENICUCCI.
Simone is the Airworthiness manager within DRONUS. He started his career in the drone industry in 2014 and joined DRONUS in 2019. He has went through ENAC design certification to enable urban scenario of 3 types of drones manufactured by different companies, Sky Robotic, EDS Ingeniera di Sistemi and DRONUS. He worked also on ARMA-Aero, the Italian military aviation authority, for the certification of one of the drones listed before. And he has recently achieved the EASA design verification M2 completion for the DRONUS Key 250 drone. He is currently engaged on the next steps on the enhanced containment for the same drone and also completion of a sail-free activity. Simone was graduated on a master in aeronautical engineering in Roma, and he has a PhD on quality management system and project management. He's also a member of UNAVIA and ASD STAN working groups, and involved obviously very actively in all UAS standards around the place. All right. And we have Emmanuele. Emmanuele.
Good morning.
Welcome also from Leonardo Helicopter Division. Emmanuele is currently the head of airworthiness of Leonardo Helicopter Division and the safety manager for the design organization. Emmanuele started in 2006 in Leonardo Helicopter on the 139 programs, where he really consolidated his knowledge. In 2007, he was also in charge of the development of the first version search and rescue of this helicopter, becoming a bit later responsible for all the variants, VVIP, offshore HEMSAR, law enforcement and utility programs. And in 2015, he was appointed as the AW139 Chief Project Engineer, also responsible for the continued airworthiness. In 2017, he was also selected to be part of 2 role-making tasks in EASA for HEMS, Helicopter Emergency Medical Services Operations. And since 2019, he took the role of Head of Airworthiness, including all civil and military and unmanned programs, leading also accident investigation and prevention and safety development design department. Prior to joining Leonardo, he collaborated with International Space Station program, and today we'll be back on Earth, low-level flight, not flying high like that. And as a thermomechanical flight payload integrator for the Columbus module. And then with Eurofighter on the Joint Strike Fighter F-35. He received an aerospace engineering degree of Politecnico di Milano and a master in business administration in 2006. And lastly, Antonio Marchetto, EASA, US Policy Project Manager, Regulation Officer and Initial Airworthiness. He's coordinating all US policy within the certification directorate. So he's the master of all the processes you'll see there. He knows it by heart. He will be able to really guide you through it. Antonio has also a degree in electronics engineering and a master of science in technology management. He's involved in a lot of design verification projects for light UAS and coordinates EASA efforts in the definition on the means of compliance to the special condition light UAS. Before joining the agency, he worked in industry as chief engineer for the Italian participation in the Noron unmanned combat air vehicle at the time. So you'll see we have quite a solid panel today to discuss about how to go through UAS. And we'll start by the presentation of each a bit more in detail, I would say, of the company and what they are doing. Let's start with Flying Basket, ladies first.
But we have to pass the slides.
Yes, I think you have the, sorry, yes.
So, okay, so I will pass this way.
To the green.
Yes. Okay.
Yes.
So thank you and welcome to this panel. Thank you for the organization to allow us to be here. I will explain first when the Flying Basket journey started. Oh, sorry, with here. And we started in 2015 when the 2 brothers, Matthias and Moritz Marotta, was in the Italian Alps, and they come with the idea to use a drone for lift and delivery goods. Meantime, they notice an helicopter that bring in a good and thing for a certain mountain. After that, oh, sorry, I'm very with the microphone. So the idea came to reduce the risk of helicopters, some application, and sometimes complement the application. But this in the next years, after 2019, that was the first fly when this outcome on the research and development during 4 years. This team, diverse team, international team, support to developing, to manufacturing, to maintain and operate this drone. And this is the most important thing that we have in a company, no? The capital, human capital, no? Is the intangible active. But we have a team, and then we need for sure a product. This is our commercial product, is the FV3. This drone, the empty weight is 70 kilos, but we can carry up to 100 kilos. It's fully electric driven, and we use swappable lithium-ion battery, sorry. And for sure, we have a product, we have a team, but for sure we need customer, no? A customer that believe that this application of the drone could support them to really improve their business. But this is not only important, no, the customers. It's also we need the regulatory framework. And this was possible because in 2019, the set of rules of the drone operation became true, enter into force in December 2020. And thanks to this one, we did a lot of operation, not only in the mountain shelter. In this case, this is forestry. And we did, thanks to the Article 13, the cross-border, the unit market of the European Union. And in this case was the LVA with ANAC, because ANAC is our country, our member state, granted that. And also we have another, like with ASTO control. For example, this is 5-year antenna mountain. And we can say that at the beginning, it's a learning process, and this is so hard sometimes for all of us, no, for the stakeholder. But thanks that during the last year, all the strong collaboration between all actors was possible to improve the regulation. And the last decision in EASA, I think, was like 2 weeks ago, more or less, no, 3 weeks ago. We obtained, for example, this new means of compliance for apply for cross-border. And thanks to this one, 1 year ago cost months. This year, 1 week ago, was possible to fly in Denmark, and the cross-border was practically in 1 week, the authorization. And we also performed different operations in Switzerland, that all of us know that Volker is outside now in the European market. But this is the next, that today we are discussing here, because in this case, this operation was in an industrial area, close to urban center, we can say. And for example, the last one in December in Turin, that we fly over the Po River in Turin with a partner, with Leonardo, in a Summary Moderni project, and also with Torini City Lab, and with for Poste Italiana, where we fly from one logistic center to another. But all of this operation was performing in Sail 2. But it's true for sure that we want to escalate the business, and we need for sure Sail 3, Sail 4, and maybe on a higher risk. So this is the reason, I think, on the panel that we are here. And for sure, our mission in our company is be the worldwide leader in cargo drone for safety critical application. Safety is a used word that we all of us love it. But in this case, we really compromise that when if something happens, any incident, although it's not mandatory to report, we consider that it's very good for all the industry, for all the community to report the incident, because this lesson learned support to enhance the regulation, to learn about the failure, doing by failure, learning by failure. And this is key for all of us. And we really compromise. And I know that Antonio knows that the last year we have an issue, and we reported to EASA. And continue it. Today I also represent the industry. I co-leading with Frederick, that is there, with Wim Cooper, one task in the subgroup 4. Related to support the development of means of compliance for EASA special conditions like US medium risk. The way that we work there is we decided in the work plan after 4 months more or less from October, we did several surveys, and we decided to divide it by subpart, the subpart that we have in the special condition. But still we have a subpart that is orphan, the subpart E. So here I offer all of you, all industry members, to collaborate. And in case that you are really interested to support us, please come to Frederick or to me, because we are really happy, and I think also EASA, because steel propulsion and energy storage is orphan. So we need to continue it. And the idea of this one is to have more or less a maturity document for open consultation on the Q3, so after summer of 2022, and for the publication next year, at the beginning of the next year. The first idea was to have an iteration, a brainstorming, to define the prescriptive elements that maybe the existing or if in case that we need new standard, may have to demonstrate this design objective requirement. But we don't want to start from scratch. We will use the available standard that current SDO is working on it. For example, we also have like a consort for Airworthiness drone that did a good work and use what they proposed. We will review for sure. Also, FAA asked to ANSI to prepare this standardization roadmap. We can also use STANAC that Emmanuelle later we can share with us the experience in military certification. And for sure, we have a HDS stand for open category. For sure, we can also review it and maybe use it. And we are focused on priorities. We divide it, and they make a kind of survey. What was the priority of the industry, the requirement? We all not focus on all of them. And also what was the requirement that the priorities for EASA, we match, and this is the result. But we are talking about that we are preparing for we can say the analytical approach. As all of you know, few weeks also, EASA published a functional test-based means of compliance. So some of this one that I remark like a border is like you can, for sure, if you decided this approach, you can demonstrate and substantiate the compliance of the requirement. But here we also talk about design verification challenge that we are faced up, all of us in the industry, because it's not easy for sure, no? And related to the means of compliance and the design verification for containment, we have today Ronald with the experience of Volocopter. For in case of mitigation mean linked with design, M2, we have also here Simone that will explain his experience. And in our case, we have also the functional test basis. And I want to share with you my thoughts. And what do you think? I invite all of you later talk openly. That still, I appreciated that this design verification for Shale 3 is a kind of exercise quite similar to type certificate. Sometimes also started with these 3,000 fly hours. Also, you can read this paragraph, no? Applicant could consider to claim functional fly hours, operated in lower sail, a kind of reliability ground model that you start with maybe lower, but you freeze the configuration, and maybe with the steering gate you can then use it. Still, I consider that there is a wide variety of application from US manufacturers that not always we can easily verify the design for Sail 3. Sometimes the effort is so huge and not flexible for kind of, I put my example of my company, sometimes customer come us and we need to modify the configuration. So if we need, every time that we submit an operational authorization to ENAC, in this case it's our NAA, and then we need to go through this design verification or just the piece of the chain modification, because it's a configuration chain, and put the effort to verify this piece, and maybe the investment with the revenue that we obtain from the customer kill all business, deadly, just a software release change, whatever. So we think that we need to be proportionate to the risk of the operation, the risk of the Sail 3. And for sure, this is another challenge that I face up, is like the functional test basis could not cover all the requirements, to substantiate all the requirements. You need to further continue to look for another kind of means of compliance. And this is still open. Maybe in EuroCai, I have the co-chair here of the Working Group 105. We can support EASA in the future with this kind of task. So I have nothing to add, so I give the floor to my colleagues. So thank you.
Thank you, Marta. I just take the opportunity to remind the audience that the functional test-based means of compliance is open for consultation, and you have 4 days to go still. Yes. So. Please, exactly, including a complete weekend. So if you have nothing to read this weekend, you can really go through it. It's important to have your feedback. We have one here, but take the chance. It's your industry, it's your operations. Try to see how it will impact it, how you put it in practice, and give the feedback. Because if it's for consultation, it's for something. It's really to get. Something. I've reminded the Slido code already. But, yes, I will do again after. So let's move to Volocopter, another kind of drone. If we can launch the presentation. Yes, okay. Here you go, Ronald.
Great, thank you. So first of all, thank you very much on a personal note to being here. It's really good to see that huge audience and that amount of interest. And when a couple of years ago, when we met the last time physically, I was here also on the panel for my company, dealing with standards on the open category. So I definitely enjoy the learning curve on both sides when it comes to. Now we have the first set of experience where we can exchange, but when we have sit together in the first time developing all this concept of Sora, and as Natale introduced all the different terms, right? There are a lot of terms, OSOs, sail level. I think now we are in a maturity stage to understand what is behind, and I really like that we get now deeper and discuss, is that what we have developed in the beginning? Does it work? Can we commercialize this effort? And I think that's really what I would like to discuss with you today, and I'm happy that we have the chance now. So first of all, I hope you yesterday have seen the Volocopter presentation from Florian Reuter. So Volocopter itself is not only the eVTOL. So of course, Volocopter will develop an air taxi, the eVTOL, which will be certified under the new EASA as eVTOL. So that's not the topic for today. But also the Volodrone, which we have developed, will be in the future kind of working on the same platform delivery. So meaning that what we are doing with Volodrone has a clear target to be in the future a certified product under the SC-VTOL together with the CSUS. Meaning we are compromised by the highest level of safety to be achieved to 10 to the -9 for the Volocity and for the Volodrone. But what we have done and the experience we share is it's not there from now on. So we need also to learn how to get there. And we want to make use of the Sora methodology, which have been implemented successfully by EASA. And there's a lot of room to test and verify these different elements from the beginning and make use of this methodology. And just a very sneak preview on the test we made on the Volocity. I think that's also the learning curve we need to take. We have done over thousands of test flights with the different vehicles and different combination coming from the piloted aircraft, from the Volocity platform, even to the Volodrone. And I think that kind of lessons we learned there is really crucial also to have the direct exchange with EASA on the certification, but also on the constant rulemaking where we are happy to provide our contribution. Only a short information about the Volocity, because you will see it flying in a minute on the video. So this will be our first commercial product, which we are currently certifying under the Future SC-VTOL. It's two-seater. You see it will have 18 motors. It has a safety level 10 to the -9, which we are committed to achieve. What Volocopter makes not special, but where we are committed to, that we are in the whole company organization preparing ourselves to be a certified entity as such. So not only producing the drone, but also developing the whole company to be ready for commercial operation for the air taxi, but also for the future Volodrone. Meaning that we already have a DOA achieved, we have a POA already, and we have for the Volocity the certification plan approved. And also we are currently preparing for the AOC requirements together with the EASA being there as well. So that's our clear mission we want to achieve, where the Volodrone will fit in. Here, that's where I said, you see the Volocity flying. This is our so-called V2X platform, which we have successfully demonstrated in Paris. Here, this was the first DVR which ever have been approved. I think from the timing, this was just short after the release of the regulation. This was a situation when this was a remotely piloted configuration in the area where we have made use as a manufacturer and operator of the Sora methodology, because from the framework perspective, we appreciate that there is a possibility now to assess the risk of a remotely piloted flight. And we used the Sora methodology. The sail level here of this operation by itself was a sail 2 operation. So we have committed, so we have conducted a Sora risk assessment, we have provided the CONOPS, and the all-of-over assessment leads to the sail 2 environment. But of course, there was the possible risk of the step 9 of Sora, the enhanced containment, where from an historical perspective in the learning process, just immediately there was the UK incident before, where I think it was also a kind of being on the safe side, not to do something completely unreasonable, where we appreciated to have the chance also together with the EASA to use that design verification as a kind of learning curve for us and also for EASA, I think, to test and verify what does the design verification brings you. And I think that's these lessons learned on this stage with all that background were reasonable, but still not from a Sora perspective, because as I said, it's a sail 2 operation where if you would stick to the methodology only, the DVR would not have been needed. Here is our Volodrone, which we are currently developing. So the Volodrone here is a platform which is also not the full-scale platform later on. So it will be developed, or is in the current development, up to a sail 4 operation. So we want to make use of the Sora methodology and of the EU-specific category to fly as much as we can and learn, and also even develop commercial operations for this platform. But you see here also in the long-term vision, it fits into our overall strategy of 10 to the -9. We have conducted a very successful test flight in Hamburg last year, where we also go the same way. We have prepared a CONOPS. We have conducted the Sora. It was a sail 2 operation. Again, we have mitigated the risk around that operation with a dedicated area, with also closing or segregating the airspace. So we have make use of the mitigation possibilities on the operational side to reduce the risk to as much as we can. And at the end, it was a sail 2 operation again. And here it shows that Sora, even if you use 2 different platforms, you can use this methodology on a standardized way. Here also the authority have been gained a lot of learning due to this, and it shows also the confidence of that methodology on both sides. And I really appreciate that we can make use of the learnings we have taken from the Volocity, make use of it for the Volodrone, and define a kind of comprehensive way to conduct flights in different regions and on different areas. I think that's the most added value we see from the Sora as such, that this is a standardized process which helps all the authority and also the manufacturer and operator to be really on a kind of standardized way to prepare this. Yes. I was told to keep myself short, and I'm happy to also listen to the other presentations. But really, I think what Marta has said, there is a challenge when it comes to the design verification process, meaning that we have this tool where the EASA Sora as such has been proven, or at least is the right direction to test and verify and do operations. And I think what we all need from the industry is the possibility to test and explore on both sides, the methodology, but also learn from what we have done. And this specific category is the perfect environment to test it. And for us, I think one of the major challenges we will have in the future is to make use of this methodology. So the Sora, but at the moment until SAE4 only, or SAE3 is already a challenge. But we need a clear pathway. How can we make use from the SAE3 to SAE4 environment, which is also already a challenge, but from a perspective of that we want to enter the certification level, that we want to find the pathway, that we can make use as much as we can of the learnings now, to not start again once we are entering the certified category. I think that's really crucial to continue this pathway, but also develop mechanisms to not just start again when we are entering the certified category, but use the learnings now from the specific category and take that over into a very good roadmap then for the certified. Thank you.
Thank you very much, Ronald, for that. The next one, after the big drones, let's go to the smaller one with Simone. And Simone, please.
Okay, first of all, thank you to EASA for the invitation to this workshop. For us, it's the first time, and we are very proud about it. A brief introduction of DRONUS. DRONUS is an Italian startup founded in 2018, has its quarter in Trieste and another operative office in Rome, where I am. It became a public limited company in 2019 with the formation of the NewCo that put together a significant startup crucial in its initial phase of development. In October 2020, DRONUS acquired the majority of Sierra Robotics, another Italian drone company, and expanded its product range to tactical drones. Today, we are about 40 people in DRONUS. DRONUS design, produce, and sells mainly 2 kinds of drones that are the Radon ISR and the K215 with its docking station called Nest. The Radon ISR is a fixed-wing VTOL with VTOL capability, has a wingspan of 2.5 meters, has a maximum takeoff weight of 9 kilograms, and a maximum payload of 2 kilograms. Here you can see a picture of an installation of our Nest. As you can see, it looks like a traffic light, a traffic lamp, so it is completely non-invasive in the surrounded environment. It is a patented solution. It is the storage and recharge basis of the drone. We don't have takeoff and landing phase. We have release phase and nesting phase. Here you can see the nest close and open. For these two kind of drones, we asked three design verification projects to EASA. For the K250, we asked M2 mitigation with high level of robustness. Always, again, for the K2050, we asked the step 9 enhanced containment, while for the Radon ISR, we asked the complete Sail 3 verification. Where we are. 2 weeks ago, we obtained the M2 high-level robustness of the K250, and I am proud to show to you it in this context. And for the enhanced containment, we had the kickoff meeting last week, right, Antonio? Yes, last week. Yeah, but we agreed with the EASA expert to wait for the updated MockLite UAS 2511, expected in 2 or 3 weeks. And for the Sail 3 Radon ISR, actually in last year we asked for Sail 4, but we understood that in this process is better to use a step-by-step approach. So we changed the request in Sail 3, but at the moment this process is in standby because DRONUS decided to focus on K250. I think it's important in this slide to show which are the areas involved in a DVR, in complete DVR, that are flight and human factors, structures, flight control system, electrical and avionics, noise, software and cybersecurity, safety assessment, and propulsion. You can see the comment that will finish in 4 days about the functional test-based mock. Then I have another slide, but if you agree, I prefer to talk about this during the workshop because we define with the expert of EASA a path, a general path to permit to a company to achieve the DVR. So because a small medium enterprise decided to certificate a drone, decided to have a DVR. And the first question is, yes, what should I do? And so now we think we have exact steps to follow. I'd finish.
Thank you, Simone. Emmanuele,
Yeah.
up to you.
Okay. The clicker is the green button. Yeah.
Need to
Take your time. In the meantime, good morning, everybody, again. And I was asked to report here an experience from one of our products in Leonardo helicopters that are becoming more and more close to this world. And this very short presentation will give you an overview about what we did in the military environment to get a military type certificate on this product. And then now the journey that we start with the EASA and the other stakeholders to understand in which way we can fit and slim this product in this unmanned environment. The background of the W Hero is that it is a single pilot tactical RSPS aircraft for area for surveillance, patrolling, and supporting other assets during the flights. This is a fully articulated rotor, so it's different with respect to the electrical engine and electrical rotor that you are looking here in the symposium. And it's to me, it's a little bit more similar on a classic helicopter than on a drones. So it's very interesting now to understand if we can merge together the two things. So I was sitting in this workshop and listening about 10-9 safety and so on. So it will be very interesting to understand how we can put together the information and the design articulated. As you can see, you have a sensor. We are not cheap. We have triplex GPS. We have a version with also a radar and the DSB, so another locator beacon. So it's a full machine ready to fly in a congested environment, hostile environments, and fully integrated with other assets, as I said before. Sorry. The evolution of our products portfolio is taking very seriously also the unmanned air vehicle. The red stream for us, it's very challenging. And this is one opportunity to see our capabilities and our safety assets with respect to the business plan that Marta and Ronald mentioned before to me about the cost and the revenues that we can do with this kind of object. So we tend to consider the design and the certification phase of these objects like an helicopter. So the cost is suddenly increased when you start to talk about maintainability, reliability, and safety. So it would be very interesting to understand how we can work together, merge together this context. Aero is not mature in terms of development. We want to enhance the platform. We want to introduce the technology that has in this time period very popping up in the market in order to have a smart platform that can be used with different applications. And for us, there are a lot of enabling technology that can be used and can be shared with the community. So one of the targets for us is also to understand what's coming from the workshop, which is the point of view, other technology, taking account of safety and cost for sure, in order to integrate a better platform together. And we realized that this is not anymore a classing exercise. We need to be connected together. So we are in the workshop, we are in the working group, we are in room-making task, we are connected with the EASA, FAA, Eurocontrol. We need to understand how the environment is changing, is consolidating to have something that can be affordable outside. So I was asked to give you an example of what we did on the military type certificate. As you may know, NATO developed and issues 4 standards for the UAS products, and we follow almost all of them in order to identify the best requirements for a certification base applicable to the Hero. It has been certified with the Italian military authority, aviation authority. At this stage, the certification requires us to have further investigation aspects like flying over congested area into no icing condition and into hail. It was a very important example to us to work together also with the Italian civil authority in order to have a mutual understanding about Sora concept, permit to fly, and activity that have to be done in a congested environment that we flew on. When we finished and we get the certification last year, we tried to start to have a mapping activity with respect to the special condition released to the EASA. And what we identify as a main differences is that the path that we follow in the military environment is a prescriptive design approach. It was not an operative-centric approach, which is very different in terms of designing and put together the means of compliance for the aircraft. And this something that maybe we can discuss today, because this kind of approach changed literally the way to approach the design of a blade or an engine on a landing gear. And what we did is try to put together this difference on the subparts from military and civil ones. And what we did is a preliminary analysis that would say that more or less more than almost 30% of the requirements released by in the civil world by EASA are already covered by the military application. And the perimeter of the requirements and the means of evidence that we have to release to the military environment according to the standards are much more higher. So this doesn't mean that we over-design or over-certify the Hero, and the Hero is ready to go in EASA, but it's something that could be for sure a good first step to approach the coming civil certification for the platform. And the third step for us would be consolidate the CONOPS. I know the EASA is asking us the CONOPS on this platform, but we are a little bit shy because we don't know what's happening outside in terms of operating environment and the business cases. So for sure, for us, the CONOPS will be the first step, together with a very deep dive analysis on the Sora. That is a very common acronyms in these days, yeah. And we want also to have this kind of feedback, not only from the authority, but also for the customers. So for UGP customers, for instance, this kind of product could be useful for pipeline patrolling or controlling video surveillance and so on. So this kind of CONOPS will be, I would say, a preliminary design review about the project overall. After that, we want to consolidate with the EASA our type certificate basis for the Hero according to the special condition and the gap analysis that we did before. And then we want to provide, hopefully, by releasing the cost of the development and certification, what we did in the military environment, because what we discovered is that military approach and civil approach are very close together. So there is no particular difference in terms of means of compliance, documentation, and so on. So it could be a challenge, but could be also an interesting point of discussion to have EASA that listen and approve what we did in a military environment. It's something that could be, to me, mature enough in these days to achieve. So the fourth step is just what I'm saying. So try to get merging together the collectivity and what we did in the past. That's it. Quick
Thank
and
you very much, Emmanuele. And last but not least, Antonio,
Yes, David.
up to you.
So, green. Does that work?
No.
Okay.
Not yet, it's coming.
Coming. Okay, here we are. So, good morning. Very happy to be here, and all this presentation has been very interesting. A good exposure to the needs and concerns also of industry, and but also some positive remarks. And thank you very much. So, first of all, just to set the stage, a slide that you have seen in so many different shapes, our three categories of operation: open, specific, and certified. And the two regulations mentioned there, 945 and 947, which set the frame for the open and the specific. Today we are really, in particular, talking of the specific category of operation, but we'll spend also some words on what will come later. So, sorry, go back. Let's go back of one slide. Yes. This slide presents the frame of the open, specific, and certified with respect to the product as we see today. And you see the open category is based on a declaration, and this CE marking that we will have on the classes of drones. Then the specific category. So here we have a frame in which for sale 1 and 2 for the product, we are not in need of any design verification or certificate provided by EASA on the design of the drone. For the sale 5 and 6, what we call high risk, you see that the arrow points toward part 21. And in that case, a type certificate is expected according to part 21, as well as for the certified category operation, which will come later. And we will spend a word on the adaptation of Part 21 that we are going through in this period. And then what do we have in the middle? We have sail 3 and 4, what we call medium risk usually. And there is a lot going on there, as well as in specific needs for the enhanced containment, and which I've mentioned before with Ronald in particular, and regarding mitigation means linked with design. In these cases, you see, there is an NAA choice, according to our regulation today, to request a DVR, design verification report. Especially Natale, who is there, is reminded in several occasions that we warmly recommend for these categories of risk to request a design verification report. However, there is always the possibility also, according to the current regulation, to accept the declaration. So this is the frame in which we move, and regarding, in fact, this design verification report, there is a design verification process, and the next slide is touching on this. We have issued guidelines for the design verification projects end of March last year, so about 1 year ago. In the meantime, we have also made experience, of course, because it's a learning curve also for us in EASA. We have provided some design verification report, and we have applications which are going through the process. In the case of design verification report, we have special condition light UAS, which is used as a, I cannot say type certification basis, I have to say design verification basis. And so let's look at the scope for design verification project, which are linked with the based on the mitigation means M2 to achieve these -1 or -2 points, which can be claimed the Sora frame for the ground risk, and are linked with design, because today we are really speaking of design. Then this is linked with a quite generic, actually, requirement in special condition light UAS 2512, which points back to the Sora and what the Sora expressed in terms of prescriptions. Then we have a design verification process linked with containment. We have several of these projects today in EASA. And this is linked with the requirement 2511 of the special condition. And then, regarding SAIL 3 and 4, we have actually all other requirements of the special condition light UAS. So once we have the requirement, we have mentioned the requirement, the next question is, yes, but the means of compliance to this requirement. And here we are. So for light UAS 2510, 11, and 12, we are focused in EASA working on those. On 2510, we have had, in particular, exchanges, and there is some interaction with subgroup 4, and I believe a finalization of a standard ED280, if I remember well, Marta. Regarding 2511, we have proposed in consultation months ago a means of compliance. We have gone through discussion. We have received many comments. We have gone through discussion again with JAROS, but then with the national aviation authorities recently on that. And so we have a way ahead, as discussed with the national aviation authorities in particular, that we can touch more in detail later, if you wish. And regarding 2512, very interesting means of compliance regarding mitigation means means M2, as they are called by the Sora. Here we are really working intensely on a document that has, and we have presented the principle recently in Rotorcraft Safety Board with David. It was a very interesting occasion also to have other colleagues involved in the matter. We are really speaking here of, first of all, safety objective and then methodologies to demonstrate how these safety objectives are reached in order to get this -1 or -2 points based on design. So basically the fact that with regard to people on ground, there is a decrease of the risk of 10 times or 100 times, looked in a quantitative way. And then there are other prescription, but the basic prescription is linked to this consideration. And I think in a few weeks, perhaps we will be able not to go to a public consultation, because what we would like to do is something more, let's say, informal first, and share it with Eurokai, share with JARS, share with the national aviation authorities. And actually it has worked quite well for the functional test-based methodology, because we have gone through this informal consultation, so to say, and we have received comments, also not promising that we will publish a CRD for these comments, which was also an advantage for us, because, you know, not having to formally reply to the CRD and at first this informal phase can be a smart way to go. And regarding this functional test-based methodology, it has been mentioned before, it is now in public consultation until, probably it's wrong, probably it's April 4 and not 6. However, if you need some days more, you write us, and we have no problem to grant some days more. And it's important because also talking yesterday with doing some networking with potential applicants or current applicants regarding this functional test-based means of complying, which is very much based on a lot of tests, 3,000 flight hours as mentioned by Marta, but with some very good elements of flexibility, which were there before, but now are even more. And they could even improve. If we will receive comments, then we can further improve the document. I happen to think, for example, talking with yesterday with colleagues, with industry, there is a principle, there is a statistical principle behind that, which links the 10 to the -3 to of the sail 3 through to 3,000 flight hours in principle. But that is also linked to a 95% confidence level, because everything in statistics, you know, you run every experiment, you're never sure, you're never 100% sure of the outcome. The more you run experiments, the more you're confident. We had no challenge regarding this 95%, for example. It is a number put there. Of course, if you would decrease the 95 to 90, for example, you would decrease the number of experiments, the number of flight hours. So that could be a possible area of comments. I'm not suggesting, but another topic is up to sail 3. The document before being distributed outside was not limited to sail 3. Then it was circulated in EASA, because of course we have to go through a formal consultation internally before providing it externally. And after this informal review, internal review, then it was for the moment limited to sail 3. I don't think we had comments in the informal phase of consultation to possibly extend it a bit after beyond sail 3. If I look at the durability and reliability of the FAA, I think they have also the possibility to run even 7,000 flight hours, which would indicate that they go actually with this method, durability, reliability, reflecting this functional test base, even beyond a sail 3, because the sail 3 is linked to the 3,000. Although a sail 4 for us would be 30,000, that doesn't seem very practical. But so, okay, just to invite, this is a good occasion to invite for further comments. Now, just a reminder regarding the safety objectives represented by the sail, because sometimes they are not very clear. So you see that basically this picture shows that a loss of control, LOC means loss of control, and a probability of loss of control. This is represented by the sail. And the probability of loss of control really is supposed to be 10 to the minus sail. So sail 1, 10 to the minus 1, sail 6, 10 to the minus 6 per flight hour. And of course, this loss of control can happen for system reason, for the drone, for drone reason, the product, but even for other reasons, as you see there. I don't want to now to enter in very technical discussion, but this is the basic idea behind. And this would lead us also, going to the sail 6 to touch on what is coming after. We are really in the high risk. 10 to the minus 6 means probability of loss of control very low. If you assume, for example, that the catastrophic failures are 10, you would need a probability of 10 to the minus 7 for each catastrophic failure. If they are 100, then you would need 10 to the minus 8. And so you see that little by little, we would reach, even in the specific category, the 10 to the minus 9 that was mentioned by Roland before. And this is natural, because when you transport people, but even when you don't transport people, Roland made the example of the Volod drone, then they have this 10 to the minus 9 objective. Volocopter has this objective. And actually, we are converging there little by little. And regarding, in fact, the high risk and what comes after, which is a certified category of operations, I wanted just to remind that we have this the Part 21 adapted for UIS. We have worked a lot last year and this year, also with a working group of industry and national aviation authorities. And we have it now inside the NPA for urban air mobility, which is the first one, and is being consulted in these days in EASA before providing it probably May, as it was said yesterday, in public consultation. And then I wanted to put this picture also because after the Part 21 is high level, procedural level, but then what do we have at a lower level? What is the certification specification architecture that we have in mind? And you find this picture in the so-called concept paper or the certified category for who has seen it. And you see the concept is that when you go for higher risk operation, a certified category operation, then the special organization light UAS and the future certification specification light UAS might not be the adequate vehicle. And we may have instead CS VTOL, but complemented with elements, you see the green vertical line, CS UAS, complemented with elements typical for unmanned aircraft, so dedicated to the command unit, dedicated to autonomous operation, dedicated to the command and control link. So this would be the idea. But in other cases, we might take inspiration and basis from other CS. You see all the CS listed there, CS 25, 23, and so on and so forth. So we would build the certification basis that way. Probably this is the last slide. Yes.
Thank you, Antonio. I think we'll have to prove a bit of adaptability, so I will skip some of the questions. I'm sorry, because I think it's important for the audience. We have 25 minutes left. First to ask questions, so please be reminded of the Slido. I remind the number 43765. Don't hesitate, because that's to answer your questions. What I'll do is more, ask our panel member to share their hands-on experience and what they felt went well. So let's start with DRONUS maybe, on really, from the application up to the first report that you've achieved. What was the hurdles? What went well? What would be the tip for our audience on a similar kind of job?
The presentation.
Yes, can you go back to the
presentation?
Presentation number 3?
Antonio, can you give me? As I said before, for us it's important to highlight this aspect. We define with the EASA expert, and I thank you very much, Cristina Angulo, the project certification manager that follow us in these three processes. We defined a general path that every company can follow to request a design verification report. Here there are the steps. The first step is the applicant send to EASA presentation in which system is described. Then there is a kickoff or familiarization meeting between applicant technicians and the EASA expert. There is the definition of the MOCs. Then a series of meetings. And I have to say that the collaboration with EASA is continuous and very helpful. If you ask for a DVR, you can ask everything, every doubts to EASA, and there is a continuous collaboration. After applicant and EASA interaction through mails and conference call, the applicant send the design verification program, EASA comments. After the DV program agreed by EASA, the applicant proceed with the testing, and then after EASA review the compliance document, the DV report is issued. So I think the most important lesson learned is that there is a strong collaboration with EASA when you perform one of these DVR.
So if I sum up, don't be afraid, you could apply and we will answer. I mean, that's really, instead of, sometimes being stuck in front of a piece of paper, just do it and it will go through the process. Maybe on Volocopter, so design verification versus certification for you, what's the driving factors and where are you on that? What you would...
Okay, so hope you can hear me. Yeah. So if we see our clear pathway, the certification is our target goal, right? So we are committed to do the certification in the future under the SC-VTOL, and then you already showed very well with the drone we will enter in the CSUS phase. I think what is crucial for everyone, not only us, is to make use as much as we can of the specific category, to really do an iterative approach, learning, create that confidence in the say 1, say 2, but don't stop on it. And for the design verification project we have made with EASA in the beginning, I think there was a clear momentum with the regulation to test it and learn from each other and sit together. And I think what I've learned, this whole process took 6 weeks. From application until verification, and I think that also shows the willingness and commitment. But we should not end up, and I think that's also a risk. What we perceive to have the situation when the applicant doesn't really know in that say 2 to say 3, 4 environment. Maybe with one national authority it works, with the other not, then we need to go through EASA, so that there's a lot of uncertainty about the process as such. But as you said, maybe get a better exchange and get a more practical knowledge on when we need a DVR, and also where we really need DVR, or where we can also build a trustful relationship with the EASA and the national authorities to test and verify our products in a constant way. Because I think we will only learn when we continuously be able to fly, and when we, especially what I said in the beginning, take over that lessons learned to the certified category, right? Because at the moment, everything what we're doing in the specific category is set up to say 4, but we need to make use of this lessons learned also with the DVR in some extent, saying this is not the end of the applications we will see, but we need to make these lessons learned and make that be used, right? To not start again in the certified category, say, okay, now everything has changed, the rules are different, we need to do a higher confidence, but what credits can we take out of that, flights and applications, and take that over?
Thank you, very good. I think the stepped approach is indeed a very practical way to go, and how to take credit of the previous step is a key point to enable industry to grow and to go up to the certified category, which at the end of the day, most of you are willing to do, because it will enable quite a huge number of operations that are not possible today. Marta, where is EuroKA working group? So you've presented a bit, but what are the timelines in terms of standard development on EuroKA side? How you see the future on this activity, and what's the next steps?
Well, as I remarked before, we are in the ESA side to support the design verification, and the ESA side to do a kind of first layer for sure. As commented by Ronald, needs to have lesson learned from the different applicant and to mature a little bit also the special condition, no? The prescriptive element. But the timeline that we managed, I presented before, was at the end of this year for the first layer, more or less. And depend us on the time, because it's a challenge for us. So not only the subgroup 4 is working on it, we have also a collaboration with other working groups, other SDOs, as I explained you before. So this is a challenge, but yeah, it's a time frame. You know, we will see what happens at the end of this phase, at more or less at the end of April, and we will decide with the real time frame and the work plan. Because today there are a lot of question marks on the table.
And I guess it depends also on the workforce you will have behind, and here also.
For sure, I will really strongly recommend to this is as far as we collaborate, all the actors, all the stakeholders together, I think faster we move. So this is so important for sure. No? I remark always in all the meetings, I think all of, you know, Antonio also asked it, Volker that today could not join us, that we really needed this support from the industry because all of us are interested to scale up the business. So, yeah.
Yes, I can only relay that. The more workforce we have in these standards, the quicker it will get through it, and also the more, the broader view we'll have to elaborate this kind of meaningful stuff. And what we see is that each time we are publishing something, there is a wave of applications coming in because from uncertainties to a way forward, it's a leapfrog each time. And the quicker we are, the quicker the industry will grow, and it's your industry, so take advantage of that. And I really contact Marta for anything on the working group, already.
Corner, don't escape.
Yes,
call it with me.
Very good. On maybe Emmanuele, sorry, on the military experience, and you mentioned a bit of the transfer, how it's could work. What is your feeling on the STANAG versus means of compliance, EuroKA, and how we can really blend those things together?
Yeah, well, the exercise we done reports that they are very close. The way to approach the statistics analysis and the reliability operability is very similar. So this means that the means of compliance and after all the means of evidence to report is very, very similar. So it could be an advantage to bring this experience also in this kind of discussion at this stage. So it's very important to us. So they are not so far away, the two words. The tricky point, the point of attention to me is well identify the Sora, which is maybe the winning point to get a differentiation between a classic helicopter and a new urban air mobility for certified category, because the risk to have too much requirements to fulfill or too much evidence to reply will increase the cost, so will put at risk the business case that Marta mentioned before. So this is something that we have to explore very well. So to me, the operational approach that I showed before is very important and maybe the driver to get a successful exercise.
Thank you. I think we have 15 minutes to go. Maybe we'll take questions from the Slido, and maybe you will have more coming in. So there is a question on when a manufacturer applies for a standalone M2 high mitigation or an enhanced containment DVR, will EASA also verify the other components of the drone as a mandatory part of the design verification process? Maybe Antonio, you're the best placed.
Yeah, thank you, David. It depends really on the means that are used to demonstrate, for example, the enhanced containment. If it is based on the flight termination system, we have this published, this means a consultation, and then we will adopt it, focusing very much on the flight termination system. So in this case, there is basically an indication, or a prescription of segregation. It is a quite simple means of compliance, a prescription of segregation of the flight termination system with respect to the drone itself, and then some quite simple test in laboratory or bench test, then ground test, and flight test, depending also because there could be the possibility to avoid flight test for relatively small drones. So in that case, yes, at the moment in which there are ground tests, then the ground tests are with the drone itself, while in the bench test, the flight termination system is checked alone, and in the flight test also. But they can be very limited. And for the mitigation means, if we have a parachute, for example, which decreases the kinetic energy when the drone reaches ground, of course, it depends on the drone, not only on the parachute, because some drones with a certain parachute may lead to a sufficient decrease of kinetic energy or other safety objective that we will describe, but other may not, depending on the weight of the drone, actually. So the drone has always some importance. This said, our intention would be in the future, after this first means of compliance on 2512 on the mitigation means, to publish a so-called means of compliance for the parachute and means of compliance for the installation of the parachute, so that applicants would have a way to go, clear and describe for the parachute and for the performance of the parachute. We may mention most probably the ASTM standard for parachute, and for the installation itself of the parachute.
Thank you, Antonio. I think you are very solicited on the chat. Sorry for that. The next one is OZO 4 at sail 3. So already is a difficult point, for all of you who knows. That's a good question for the quiz of Marta. Is a low robustness item and is therefore a manufacturer responsibility, and compliance to this requirement will have to be declared. Why does EASA use an airworthiness expert panel to accept the declaration? Sora does not mandate such a comprehensive verification for sail 3.
So, for sail 3, where we have a design verification project, we use spatial condition light UAS. Now, we have published a matrix that links, traces the operational safety objective to the requirement of the spatial condition. And from the matrix, one could see, for example, that for OZO 4, subpart B flight and subpart C structure are the main one linked to the OZO 4, only to the OZO 4, because other subparts are linked to the OZO 4, but also other OZOs. So one could say that in these cases, subpart B and subpart C, it's true, we require this evidence, but we may not look then into this evidence. Another possible way is that, as I was discussing yesterday with applicants, is that the evidence for those subparts for a sail 3 could be available at the applicants, and we may require those evidence where we think we would like to look for some reason into these evidences. So a flexible approach, not just saying they do not exist, it's just a declaration, because in some cases we may want to have a look into this subpart, but in many other cases, not.
We have a question on the cost. That's interesting, Yes. So, how much a design verification of a M2 mitigation and high robustness cost using a parachute on the drone less than 3 meters and 25 kilos? I know if some of our panel member experienced that already.
We don't have the parachute, but we have the experience of the cost.
Okay, so
And I can indicate you the exact cost, and if I don't wrong, is about 20,000 euros. EASA side. Then there is our side, but EASA side is about 20,000 euros.
So yes, I think we have a quotation. Each time you have a design verification, we provide you with a quotation. You agree or not, and then we move on. So that's how it works. And obviously, the quotation depends on the complexity of the drones and the systems that you are implementing. So that's not a one-size-fits-all, and it's tailored to your own potential application. But obviously, it has a cost. I'm sorry for that.
Yeah, this is a small drone.
This is a small one, yes.
Yeah.
But a lot of applications. Yes. Next one, how many applications have been received by EASA for a full UA, so as opposed to only just containment and design verification at cell 3 and 4?
We have, I believe we have 5 applications ongoing for a full design verification.
Good. So that's very straightforward. And also, interesting questions. Are NAAs obliged to recognize the design verification requested by a different NAA under the same CONOPS?
Well, the design verification in Europe is recognized and should be and needs to be recognized by all national aviation authorities. So we know that at the moment in which an operation is, let's say, exported from one state to the other, there is a check that the National Aviation Authority in the other state can make on the so-called local conditions. Because even if the context is completely just the same, the fact of taking it into another location can lead to a further check of regarding local conditions, local condition regarding to the operation. In this case, if ever these local conditions might hit, let's say, against some limitation which might appear in the design verification report, because in the design verification report we may have, in some cases, limitation or of some nature written, then we might need to be called back in the game for a delta of verification if needed, but due just to these local conditions.
Yes, it should be very unusual.
Yes.
We expect that it is indeed all across the board.
Exactly.
And by the way, speaking about cross-border, maybe Marta, you can speak about, because one of your points was cross-border, and we have a next question on that. If the NAA state of operator registration accepts your declaration of compliance, and you make a cross-border application, can the next NAA then request a design verification from EASA, or will you be deemed to have met the required standard for all member states when you have an initial operational authorization?
No, in according with the new means of compliance that was published in the last decision, not the only thing that when you apply for cross-border, you need to look for the mitigation of the new place in the CONOPS, and just it, the substances. So in this case, I think that not is needed to claim a design verification, for sure that not, because it's according that the first member state in your home, we can set, you apply for equivalent safe risk level of the operation. So just could ask for a claim for some mitigation, but that's all. So no.
Okay, so that's why you have only 1 week for the last export. It's very good. Next question is on will design verification issued by EASA be recognized by bilateral partner in the future? And that's a very open question. And so far, US are not in the bilaterals, so they are not covered. So the immediate answer is no. The future answer is we hope to indeed engage with our bilateral partner to have at least a good level of recognition, mutual recognitions in some design verification, or obviously type certification afterwards, but to enable a more worldwide deployment without extra efforts. And maybe Antonio, you can rebound on also the functional test, which is very similar also to our FAA colleagues.
Absolutely, because in that case we are really providing for some convergence in the methodology, and then I would expect that there could be the possibility also to develop some bilateral agreement in the future for the functional test bed.
So, and last questions before I give 1 minute to every panel member to sum up and the main takeaway for the audience. Why is EASA deviating from the JARUS recommendation and imposes the use of an airworthiness standards for Tail 3, OSO 4, still OSO 4, this one is, while JARUS Sora Sail 3 has not such a requirement and is used by countries outside Europe?
The fact is that at the moment in which we have a Sail 3, as it was shown with the slides, we have included, first of all, the law for the OSO 4, because what we think is that, and this was not, let's say, as in JARUS, because for the OSO 4, the JARUS is an optional. And we continue to think that it's not good to, let's say, put an optional, meaning for structure, flight, and all which is linked to Sail 4, not have any criteria at all. They can be extremely light, but as a quick check on those aspects would be beneficial. And by the way, I have to remind that in the open category, and there is Christophe here from ISD Sun, we have criteria, we have technical criteria for the drones of the open category, which is supposed to have a lower risk than the specific category. So we have a point really of discontinuity between the open and the specific at the moment in which in the specific we would not have technical criteria. Regarding then the need of a design verification process, as the slide we're showing, it's for the Sail 3, it's not mandated. It's a choice of the National Aviation Authority. We said that for harmonization reasons, we recommend to ask for National Aviation Authority to ask for a design verification report for Sail 3, and I believe we will continue to work for this Natale to make it harmonized but light, as it should be. But by the way, let me say, the functional test-based approach can be a good vehicle because with all the flexibility we are building in it, and if you help us further with the comments to build even more flexibility, that could really be a potentially very light approach to put a stamp, so to say, on a drone for Sail 3 and have operations quite quickly, and then build, if we would even expand, if we would receive comments to expand on higher Sail 4, and we would accept those comments, operations carried out in Sail 3 could be, commercial operation I mean, could be used, flight hours, could be used to build up for riskier operation, but already carrying out commercial operation in Sail 3. So you understand what I mean?
Very good. Just last one question because it's an interesting one. So has it been considered to provide a guidance material instead of a design verification process for Sail 1 and 2? Please.
Sail 1 and 2.
Basically.
Sail 1 and 2, we don't have a design verification process. So at this very moment, we don't have any technical standards linked to that. Although I think in the future we may consider to have also technical standard but that would be only the clarity.
Okay, so thank you. Let's have the last word. So in the order, so Marta, ladies first, please.
So thank you. Please remind that the workforce is so important. So please comment on the functional test-based public consultation. remind, if you really think that is proportionate for the risk of tail 3, then if not, comply. And please collaborate with ESDO, and we will
Yes, please collaborate.
collaborate in your industry, please, industry members. So.
Good. Antonio?
Yes, thank you very much. It was a great occasion to launch some important messages and have also some feedbacks and seeing what are the concerns, and we will certainly work in the direction to solve those concerns as quickly as possible.
Ronald?
Yeah, so first of all, thank you also again for that panel. I think I really want to recall again the importance from the industry to make use of the specific category as much as we can. I think what has been shown is really that we are currently at a stage, especially for the small and medium enterprises, where we need to commercialize as soon as possible, and don't forget this performance-based approach we have implemented here, and allow us to work together and to build trust and confidence due to flying and testing and verifying. And also think about giving the competency also to the declarations, saying that it's also on the manufacturers and OEMs and operators to show to the authority that they are able to manage the risk in a certain way. And I think we are on a good track, and yeah, let's support Marta in the EuroKA, let's support Christoph and ASD Stan. We need the standards to really build up a comprehensive framework.
Thank you. Emmanuele?
Yeah, the same comments, Roland. This is the momentum, this is the perfect time to connect the dot, because it's a very heterogeneous community coming from different experience, and standards and comments are now crucial to get a solid roadmap. And thank you for the invitation.
I have no particular comments, only thank you to everyone to be here in presence. Yeah.
And thank you very much. I know it's lunchtime and it's very late. We are 2-3 minutes late. I will keep it short. So for me, the main takeaway is, the best way to learn is to do it, not on paper, but really make the things happen, fly. We are here to support at EASA. We are trying our best. We cannot be everywhere, so that's why we have a lot of support from others, and we need all the community to come together to make it happen. And the next steps, next year I'm sure we'll have a few more applications, maybe much more, and much more drone flying in the sky in a commercial and viable way, and that's what we are wishing the industry to. Thank you very much, and have a nice lunch. Thank you.